नहीं, सिर्फ उसको बोला विश्वजीत को।
घड़ी वाले कितने लोग हैं? घड़ी और शॉल वाले
सर 14 घड़ी वाले 14 है, बाकी शॉल और सम्मान पत्र वाले 12।
वो भी नहीं आए ना अभी? वो मुझे दिया था।
सर वो कैंपस में है बट ऑडिटोरियम Shall I start, sir?
Good afternoon, ladies and gentlemen. It gives me immense pleasure to extend a very warm welcome to one and all present here on this very proud occasion, the 84th Foundation Day of Council of Scientific and Industrial Research, being celebrated here at CSIO Chandigarh. I am Mansi Alawat, Section Officer General, and today I am having the privilege of hosting today's very special event. At the very outset, I would like to extend a heartfelt welcome to our chief guest, Professor Venugopal Ajanta, sir, Director, CSIR National Physical Laboratory, New Delhi. A guest of honor, Dr. Sanjeev Khosla, Director, MTech, Professor Shantanu Bhattacharya, Director, CSIR-CSIO, Dr. Satish Kumar, Chief Scientist, all our distinguished guests, faculty members, staff, and students who have joined us this afternoon. Thank you for your presence. आज का यह विशेष अवसर हम सबके लिए एक अत्यंत गौरव का क्षण है जब हम मिलकर CSIR की उस अद्भुत यात्रा का उत्सव मना रहे हैं जिसने विज्ञान, अनुसंधान और नवाचार के माध्यम से भारत को नई ऊंचाइयों तक पहुंचाया है। Since its inception on 26 September 1942, CSIR has been the cradle of innovation, contributing to the nation's technological strength from aerospace to agriculture, from energy to environmental sciences. As I quote the very words of our respected DG Ma'am, Dr. N. Kalai, Foundation Day is a very, very important day for an organization like CSIR that has already completed more than 8 decades of its existence, especially in the service of Indian industries and the society. India is now passing through a very important time wherein our focus is on Atmanirbharta and self-reliance. And these two could be completely fulfilled only through innovation. In this innovation part, CSIR is taking the lead, and we are so proud to say that 37 national laboratories are coming up with a minimum of 100 plus unique technologies by means of which Indian industry, MSMEs, startups, entrepreneurs, and the society at large will get a huge benefit in the coming times. These inspiring words truly capture the essence of what CSIR stands for, the spirit of innovation, excellence, and service to the nation. Today's celebration, therefore, is not just a commemoration of CSIR's glorious past, but also a reaffirmation of our collective commitment to build a more self-reliant, technologically advanced, and innovative India, so that CSIR continues to stand tall as the innovation engine of India. Now, to mark the beginning of today's celebrations, I request Director Sir to kindly present the bouquet to our chief guest and guest of honor as a warm welcome. Thank you, sir. Now, moving ahead, every successful journey begins with vision and leadership. And at CSIR-CSIO, we are truly fortunate to be guided by a dynamic and inspiring leader whose relentless dedication continues to shape this institution's progress and innovation. It gives me great honor to invite Director Sir Professor Shantanu Bhattacharya to kindly deliver the welcome address. Please.
Respected chief guest, a very distinguished scientist and my colleague, Professor Venugopal Ajanta, Director CSIR National Physical Laboratory. Our esteemed guest of honor, another very, very distinguished scientist, Dr. Sanjeev Khosla, Director MTech, all other distinguished colleagues of mine of this great organization, students and guests. Indeed, it gives me immense pleasure today to welcome all of you on the special occasion of the 84th CSIR Foundation Day. This day holds profound significance for all of us as we come together to celebrate this extraordinary legacy which has been set up by the Council of Scientific and Industrial Research in this country. A legacy built on innovation, built on excellence, and selfless service to the nation. First and foremost, I would like to extend my heartfelt gratitude to our distinguished guests of today, both Professor Achanta as well as Professor Khosla. Your presence adds great value, great significance to our celebration here and deeply inspires all of us. We'd like to hear, from both of you, your expertise as well as, messages related to CSIR and the way it goes forward. The Foundation Day is not merely a commemoration, it is a reaffirmation of our collective commitment to the ideals envisioned by our founding leaders, starting back in 1942. Over the last 8 decades, CSIR has played a very, very defining role in shaping India's scientific and industrial landscape, from pioneering breakthroughs in materials, health and agriculture, to developing cutting-edge technologies in aerospace, energy, strategic sector, medicine, biology. CSIR's journey has been one of relentless pursuit of excellence. As we mark the 84th year of our proud legacy, we celebrate not just the past, but also promise of the future. CSIR stands at the forefront of India's innovation ecosystem today, driving technologies that touch the lives of millions of Indians and global residents. The motto of science for people continues to guide our endeavors, translating laboratory research into tangible societal outcomes with impact. At CSIR-CSIO, we have been steadfast in this mission as well. Our work in instrumentation, photonics, sensors, biomedical engineering, semiconductors, strategic domain, and optoelectronics continues to empower diverse sectors from defense to healthcare, agriculture to manufacturing, and even national security. With the recent establishment of our Center for Nano-Optic Fabrication, we are poised to take a significant leap forward in precision optics and nanofabrication research, further strengthening India's capabilities in advanced scientific instrumentation. As the world embraces the fourth industrial revolution, driven by artificial intelligence, robotics, quantum technologies, and smart manufacturing, the responsibility before us grows even greater. CSIR as a national knowledge powerhouse must continue to lead this transformation, fostering innovation that is sustainable, inclusive, and globally competitive. Our strength in collaboration between laboratories, between the academic centers of excellence of this country, and various industrial houses brings this synergy, as exemplified by our guests today, and their vision and their thought process that I will share. On this Foundation Day, let us reflect to our journey and rededicate ourselves to the values that CSIR actually does in all of us, that is excellence, integrity, curiosity, and service. Let us continue to inspire the next generation of scientists and engineers and innovators to dream big and to also make those dreams happen into the reality space. With these words, I warmly welcome once again my distinguished colleagues here on the dais, and to all of you on this 84th CSIR Foundation Day celebrations at CSIR-CSIO. May this day strengthen our resolve to push the frontiers of science and technology for a better, brighter, and self-reliant India. Thank you. Jai Hind, Jai Bharat.
Thank you, sir, for such an informative session. It is my honor and privilege to introduce our esteemed guest of honor for today's Foundation Day celebration, Dr. Sanjeev Khosla, Director of CSIR IMTech. He is a PhD from Indian Institute of Science, and he was elected into the fellowship in 2020 under the General Biology section. His specialization are epigenetics, host micro, and developmental biology. We are truly grateful to have him with us today. May I now request Dr. Sanjeev Khosla to kindly share a few words with us. Please join me in welcoming him with a big round of applause.
So, thank you very much, and it's an honor to be part of CSIO's celebration of the CSIR Foundation Day 84th. We had this celebration yesterday, and I can truly say that we belong to an organization which has served the Indian society for these 84 years, and actually the all the part of our history from our from the time we have become an independent nation. And of course, I don't need to tell the audience here the kind of societal benefits that the Indian people have got from CSIR, whether it was indelible ink or Amul milk. There are so many examples of how CSIR has touched the lives of Indian people. But I must say that the future is very bright. We are only 16 years from the 100th Foundation Day, and I think so it would be a major milestone. We are going from strength to strength, and the contributions of your director, Dr. Shantanu, Gopal from NPL actually are something that are going to make the pillars of CSIR much more stronger, and I'm very sure in the years to come we would be basking in the laurels of the great people in the audience and on the dais. So I again thank you for giving me this honor to be part of this function, and welcome to all of you to this function. Thank you.
Thank you so much, sir. Now moving ahead, we are deeply honored to have with us today Professor Venugopalachanda, Director CSIR National Physical Laboratory, New Delhi. Professor Venugopalachanda obtained his PhD Physics from TIFL Mumbai and PhD Electronics from Tokyo University. He has over 150 journal publications. He is a fellow of the Optical Society of America and the Indian National Science Academy, and an honorary fellow of the Metrology Society of India. He is currently the President of Optical Society of India and Vice President of Indian Laser Association. It is our pleasure to have you with us, sir. Now I request sir to kindly deliver the Foundation Day lecture.
First, I should thank for keeping the introduction brief, not making it embarrassing. So, thank you. Thank you, Professor Shantanu, and my fellow director here, Sanjeev, and senior most scientists here, like Dr. Satish, and all of you who are here for this Foundation Day event. When I came to CSIR, in TFR we celebrate the Founders Day. That's the birthday of Homi Baba. But in CSIR, like, we celebrate the organization, we celebrate our achievements, what we have done, what we can do together. So that's one of the reasons, like, when I was asked if I can come today, I readily agreed, because my interest is, can we look at fostering collaborations, better interactions between our labs and our people, so that, like, we can better utilize the facilities. So two areas where I can straight away see good opportunities in biomedical equipment as well as in environmental sciences. So these are two areas where our two institutes can work together. And with Sanjeev's presence, like, so I should be little politically correct, but then I'll put it bluntly, saying that, like, so the physics engineering labs are minority in CSIR system. So it's like Gol Gol Gunke, NPL, CSIO, CSIR. कुछ भी कुछ माफिया बनने के चांस ही नहीं है, तो हमको साथ में काम करना ही है, right? So let's work together, and these are areas, like, where we can really do a difference, make a difference, and especially this photonics fab facility. It's really congratulations to the team for coming up with the facilities almost within the time promised and all the facilities are up and running. So this is really a credible thing, and this is the first unique facility in the country. We should be proud about it. We should be boasting about it so that people know that such a facility exists within the country. Right? So there are common facilities, there are what they call IMUPs in IITs and IASC. There are 100 crore plus facilities, but I keep saying this. I worked on semiconductors. I made semiconductor devices. I also made nanophotonic structures. So I know the challenges. When I work on an electronic device, whether it's a 50 micron or a 20 micron pad, it doesn't make much of a difference. But when I talk about a photonic device, a 100 nanometer and a 102 nanometer makes also a lot of difference because my resonance is going to shift. Right. So we need to be extremely precise when we're making these photonic devices. So this facility has huge potential within the country and outside. So if we can overcome the challenges within and can deliver to the community for the world, right? So this will be a good opportunity for us to get visibility as well as potential for earning a lot of ECF. Right, so one of the criteria which is there for each one of us as scientists in CSIR system. Right, so going on the same lines, like so I just wanted to show. Now I'll wear a hat that like I'm from outside CSIR system. I came here, and one of the challenges I faced wherever I went, a funding agency or when I talk to somebody, it's always CSR में ना project लेते हैं लेकिन delivery नहीं होती है. Right. So our focus has been to deliver whatever projects we have taken. So what I'll show is what are our recent activities, what we have delivered, the major projects in the context of nation and in the global perspective. And I'll say like so where we can come together. Right. Thank you. Right. So again, most of you know, but for completeness sake, each country in the world has one designated institute, which is the Metrology Institute. Metrology is the science of high precision measurements. So for India, the Metrology Institute or the National Metrology Institute is NPL. Right. So most of us know about NIST in US or NPL UK or PTB Germany or something like that, but NPL is at par with any of these global national metrology institutes. Okay. So, as a fast-growing economy, we have challenges, right? So, one of them is providing the metrology traceability services to the industry, growing industry. So, if you look at the quality infrastructure in India, as can be expected, like so, we made a jalebi out of it as usual. Like so, we have standards body which is BIS. Then we have the National Standards Laboratory, which is the CSIR NPL. So the standards body's purpose is to make standards. If you want to measure one node, or if you want to measure or certify some equipment, what is the standard to follow? So that is all on paper is done by BIS, and the relevant standard of measurement is set up at NPL. And what we do is we act as a bridge between the consumer down to the consumer level, shopkeeper level, and to the international community. So whatever facility we have at NPL, so we call it calibration and measurement capability of the country. That's because like this experiment is compared with the rest of the world facilities, and a blind sample is sent from one country to the other, and every country measures this particular sample and then gives out this is our measured value, this is uncertainty. Then the pilot lab, they actually test how we measured, what is the analysis, how we calculated the uncertainty. All these things are checked, and then they say that like, okay, the value which you are claiming is okay, and a plot is made, it's an intercomparison plot. And then they say that like, okay, you have this capability of measuring this particular parameter. So once we pass that intercomparison test, which takes at least from, some of them take up to 10 years, 5 to 10 years for one single parameter for this intercomparison exercise. After that, the country is given this measurement capability. Once it is given, across 102 countries, the certificate given at NPL is accepted. So that's the international part of it. And in the local domestic community, domestic level, so what we work with the legal metrology and accreditation bodies like NABL, FDIS, IQAI. So these are private accreditation bodies also available now. And we provide traceability to them. If we go to an NABL accredited laboratory, their equipment comes to NPL and we calibrate and say that, like, yes, the values which those equipments are giving are actually correct or not. Right? That's how the entire metrology and metrological traceability works to support the quality infrastructure within the country. Right? So our challenges as a fast-growing economy is that, like, we have our needs. What are our needs? We need food security, we need clean environment, we want circular economy, we want clean energy. All these things are needs. But we have limited resources and we have aspirations. We want to be at par with the global metrology institutes. We don't want to keep on buying equipment. We also want to build our own equipment and make them available to the rest of the world. So we are working on areas like quantum metrology or metrology for quantum technologies, digital metrology, time dissemination. On the other hand, we are working on bringing the traditional knowledge under the SI units, the International System of Units. So for example, traditional medicine, Siddha and Ayush. So if you look at this traditional medicine, if you go to an Ayush or Siddha medicine, they say that like एक चुटकी भर कुछ पाउडर डाल दो या कुछ नीम का सीड है उसका सीड का वॉल्यूम का कुछ बस डालो या चूर्ण डालो something like that. So but what is that exact quantity? Right, when you say like when we are putting it with hand, it may not be same when 2 people are doing or 10 people are doing. So what we're doing is we're quantifying this measurement, the traditional measurement ways or the units, so that like they are in millimeters or whatever, like so the SI unit. So similarly, we need to bring in traditional art and craft, support the local industry, and also certified reference materials. So this is what we are trying to balance using the resources. We work with the line ministries to get as much funding as possible to support these activities. So we have 6 divisions. I'll not go through all of them. The physico-mechanical metrology, electrical electronics metrology, then we have environment and biomedical metrology, materials and device metrology, Bharati Nirdeshik Dravya under the brand name, we make these certified reference materials in the country. So for example, 85% of the water required things, so water purity testing in gel boards and all that, like so they are using the certified reference materials under the brand name of BNDs. Water BNDs, 85% self-sufficiency we have. We are making these things. Similarly, gold purity testing, silver purity testing, cement BNDs are actually getting exported to Europe and Middle East now. And Indian Standard Time is one of the best in the world. We get about 2 nanosecond uncertainty. We can give time with that kind of precision now. Right. So the recent facilities which we have, the projects which we completed and established the facilities include a solar cell calibration facility. So this we did again the inter-comparison with the 4 other facilities, such facilities which exist in the world, including China, Japan, US, and Germany. So as you can see from the last value, ours has the lowest uncertainty, or we can measure the short circuit current with the highest precision in the world. Right, so this is the best facility in the world. This is operational from July 2024. So in environmental sciences, we got last year the CSIR NPL is designated as the National Verification Agency. This is for certifying all environment monitoring equipment within the country. So we do make these environment monitoring equipment like particulate matter counters or ozone analyzers, and we transfer these technologies to the private companies. And the recent facility is what is known as a certification facility for emission and ambient air monitoring system, and also we do the type testing calibration certification facility. So this is Asia's first facility, and we already started certifying. So we have a long lineup of about 40 countries, 40 companies whose products are to be certified by November. So that's a target given by CPCB. So we're trying, people are working hard to meet these deadlines. So this is the National Time Dissemination Project. As I mentioned, Indian Standard Time is one of the highly precise times which are available across the globe. There are 90 locations from which the atomic clocks contribute across the globe to the International Atomic Time, what is known as TAI. Earlier we had the Greenwich Mean Time, now it is the TAI, which is also known as UTC, which is calculated at BIPM, the headquarters in France. So we have right now the NPL contribution to calculation of the International Atomic Time is 5th best in the world. So we have set up these 5 centers. Delhi NPL is already there. Then we have Faridabad. In the northeast, we have at Guwahati, Bhubaneswar, Bangalore. We have a disaster recovery center in case something happens as a backup to the NPL facilities, and the other one is Ahmedabad. So these 5 locations plus 1 disaster recovery center, these are all up, and hopefully in the next couple of months, this will all be contributing to the Indian Standard Time. Now, Indian Standard Time last year has been legalized, and it is mandated to all the companies and everybody to take time from NPL or one of the centers which we have in NIC, National Informatics Center. So we maintain atomic clock and time dissemination facilities there. So every company is mandated to take time from either NPL or NIC, and these 5 centers also will help in reducing the latency and get better time, better accurate time in the very near future. Right. So for circular economy, we work on futuristic ideas. Right. Among the CSIR labs in the Indian context, the plastic waste to wealth, recycling the tiles for different applications, that was pioneered at CSIR NPL over 25 years ago. We have about 14 companies which are productized the technologies from CSIR NPL. So the recent thing which we have done is to look at in a futuristic way. So the Indian government has a target of having 50% of the electricity generation from renewable sources in the next, say, by 2030. So for that, solar is one of the primary areas. So, but the problem is the solar panels also have a life cycle. So after say 15, 20, 25 years, these solar panels are going to be a huge waste. Right? In the e-waste recycling, most of the CSIR labs work on, and we focused only on precious metals, right? How to extract precious metals. But however, the silicon itself is going to be a huge challenge. Like tons of silicon is going to come out as a waste from these solar panels, dead solar panels. So we developed a method to recycle this silicon. So we achieved better than 4.9 purities already. We're trying to scale it up, or working on a method to scale up this silicon purification and also improve the purity as well. So the overall recovery rate, given a solar panel, we can recover about 92.4% of that, like including from glass to the epoxy, which is used to bind the glass to the frame, and I mean, of course, the frame itself and the precious metals, everything included, right? So that's the current status of this base silicon solar PV module recycling. So as I mentioned, Bharati Nirdesh Infravi, or the BNDs. So this is a flagship program of CSIR NPL. To make a reference material, you need 17025 or ISO 17034 facility in your lab. But to make it a certified reference material, you need to have traceability to a metrology institute, National Metrology Institute. So far, like say about few years ago, we have been getting traceability from NIST or somebody. We buy these so-called standard reference materials, and then we test our reference materials with respect to that, and then say that like how we have CRM. But now we have these BNDs which are Indian CRMs. So now we partnered with ministries of Ayush and Siddha, and also with the Pesticide Formulation Institute, so that like pesticides to even pharmaceuticals also, like, so we are trying to work on them. So we want to expand the scope of this. Right now we have around 170 BNDs in the country. We need to expand the scope to compete with countries like US or China, who have anywhere between 1500 to 2000 CRMs which they have in their portfolios. So this is something which is needed to reduce the import burden. So just to say that, like, in one of the, I mean, if you take one of the CRMs which you are importing, for example, which are needed for the bio labs, testing laboratories, the kits, we import around $1 billion worth of kits every year. So these are things which we should be able to do within our countries to reduce this import burden. So we work with several private as well as government organizations like the Cement Board, the FAIR Labs, Ashvi Technologies, BPCL for petroleum products, our sister labs like SIMFER, IITR, right? So we are expanding the scope of these BNDs. Right? So in the biomedical equipment standards, again, we have standards on paper in BIS, but we do not have the standards against which to test our equipment. So we import almost all of our biomedical equipment, but there is no testing or calibration happening on a regular intervals. In the last 3 years, we have started the certification or calibration facilities for defibrillator, infusion pump, ECG simulator. Then we have incubators with 4 different parameters like temperature, humidity, sound, light. All these parameters we can certify now. And electrical standards for biomedical equipment is also, we have done the facilities including EMI, EMC shielding and other things. Right? We can test all these things, and many of these Indian companies who make this biomedical equipment, they're coming to NPL to get their products certified or tested. This is another, PMU calibration is another important thing, so which is basically this is a phasor measurement units. So in our electricity grid, we have thousands of these PMU units which are installed. What they do is they measure the voltage, current and phase as a function of time. So this information is needed because if there is a surge at one location, how is it going to affect the different part of the country in the electricity grid? So we need to monitor these things, but this monitoring equipment, this measurement equipment, PMUs themselves are not calibrated till about 2 years ago. Now we brought in the ministry, we brought in the company which makes these things, so that like every equipment which is made before deploying and after deploying also in a periodic way, like they are getting calibrated, so that like we have better calibrated and reliable data which is coming out for us from the country. Right? So we are working on futuristic quantum metrology facilities like Kibble balance for measuring mass. We have a 10 gram and a 100 gram prototype currently working, so we are now designing the 1 kg one. So acoustic gas thermometry instead of thermometers, like, so this is a new technique by which like we can using the quantum definitions, using the Boltzmann constant instead of measuring Kelvin, we measure the Boltzmann constant, and from which we get higher precision measurement in Kelvin. So atomic clock, we are the 5th country in the world to have our own cesium fountain clock. Now we are working on next generation ytterbium optical clock. Hopefully in the next year or so, like we should have some good development coming out in these areas. In addition to setting up these quantum metrology standards with higher precision measurement techniques, we're also looking at how we can use these metrology facilities for upcoming quantum technologies. It can be materials metrology, it can be for single photon sources or detectors or high precision measurements, and what new standards which we should have for these things. Just to let you know, like we're talking about superconducting qubit or superconducting qubit-based quantum computer. These works at milli or microkelvin. How do we know that the temperature sensors are working properly or not? We don't have any calibration facility for these things. So we're working on such things, the electro-optic modulator or acoustic modulator. There's so many things, like so the cables themselves. So we have no facilities to test these things. We are working on setting up these facilities so that we don't have to send this equipment out of the country to get them tested and calibrated. Right? So these are different technologies which are used for clock or sensors, or, gyroscopes, gravimeter, non-classical light sources and detectors. We're working on most of these things at CSIR and PL. So for example, this is one thing which I'd say, like this is hot atom-based handheld quantum sensors. We can do magnetometry, magnetic field, electric field, RF field sensing. We can do signal modulation for secure communication. So I'll not bore you with all the things, but we have very advanced lab facilities where we have demonstrated these. Now we are miniaturizing these for DRDO and other stakeholders. So we are hoping that like in the next year and a half, we have these technologies for commercialization. So this is the quantum sensors. It works on the so-called electromagnetic field-induced transparency. The basic idea is that like so you have these two levels. So this is pump and a probe beam which are there. So you're basically you're exciting your electrons to these states, and then you're looking at the transition frequency which is here in the RF mode. Right? So when you apply a magnetic field or a electric field, the Zeeman or the Stark shift will shift this energy level. So the absorption or the transmission of this particular frequency will depend on the applied electric or magnetic fields. So by carefully calibrating it, we can measure down to femtotesla kind of magnetic fields. So right now we have about picotesla per square root hertz kind of sensitivity in this system. So we also showed that we can actually mix two different RF frequencies. So you can modulate, we can use it for modulating. So we're talking about single photon sources, entangled photon sources, quantum key distribution, all big things which require very fancy detectors and fancy sources. What we demonstrated is like we don't need all that. We can actually use this quantum channel for encryption and decryption, and the transmission can be through a classical channel. So that requires that reduces the burden which we need on the quantum communication channels which we have. We also made these prototypes of the single photon detectors. This one is a single superconducting nanowire based single photon detector, and then this side, like so, these are arrays of APDs, the silicon photomultipliers. Right. So we are also working on metasurfaces. These are more to make the chips for atomic clocks. There is actually a company already in US which is making such optical clocks which are basically like our wristwatches. So we made those prototypes, we tested their beam profiles, polarizations and all that, and suitability for trapping atoms or ions on top of them. So just to summarize, like so metrology is a science of high precision measurements. This forms backbone for quality infrastructure within a country. So as National Metrology Institute, we are working on traditional knowledge on one side, quantum technologies, digital metrology and other futuristic areas. So this is how we would like to continue, and we are open to collaborations. You have certain facilities and expertise, and we have certain needs and requirements. And my reason is once again say that like for coming here is to foster collaboration so that like we can work together and meet the demands of the nation. Thank you very much. I wish you all a very happy holiday. Any questions or comments, suggestions?
Yeah, I think if anybody has any questions for Professor Santa, please feel free. I mean, you have showed a diverse amount of work related to your laboratory. Obviously, our team will like to get in touch with various, common areas to connect. We do have some fabrication capability developing here. So I think it's the right platform or the right timing also for everybody to collaborate together. So any questions from the audience? I see a lot of people working in analytical areas where for example, our biomedical team could, see if there's a scope for calibration, if there's a scope for standards. They are like the standard warehouse for the country. So I think even areas where you feel that new standards need to be developed, I think we should work together closely because that's another area where new knowledge can definitely come in. Working with NPL, I know, is an advantage because they are recognized across the world. I had a chance to interact in UK with your NPL, divisions there, the scientists who came. So I think historically it started off there and then it could be here, something like that happened. So, any questions for that? For first speaker?
Yes, ma'am.
India has a single time zone.
Sorry?
India,
Yes.
single time zone.
Right.
But you have shown that we have about 5 atomic time stations. What is the logic behind it?
So one of the challenges is that how do we disseminate time? We have atomic clocks and the clock time. It's called UTC-K, which is the universal coordinated time for a particular country or particular location. So for India, the Indian Standard Time is generated at 10 p.m. Now, if somebody down in the south or in the northeast want to get that time, how do they get it? So the way we currently do is known as the network time protocol, NTP. Right? So it's through Ethernet. So what happens is that I send the ping saying that like what is the time now? And the NPL servers will give the time back. There is a latency, there is a delay in the time because of the network congestion, whatever is the reason. So these 5 centers are meant for reducing that time delays or any inaccuracies which are coming because of in the process which we do the time dissemination.
Another thing is you mentioned about that medical instruments you got from the abroad and gates also calibrated at your center. Is it like that?
Right now, not happening. Right now, what is happening is the Indian makers, for example, whether it is GE or Wipro or somebody like that, they're coming with their new equipment. And we set up these standards as per the existing BIS standards so that any new equipment, any equipment which is made in India or anybody's equipment can be brought and we can test and calibrate them. So there is one thing which you mentioned, so as Professor Shantanu mentioned, just wanted to say that there are, if you want to buy a lock-in, for example, right? So there is a lock-in which you can buy for say 5 lakhs. But the same thing, if you want a certified lock-in, for example, NIST certified lock-in, it costs anywhere up to 40 lakhs. Right? The same thing can be done at NPL. Right, but we are not utilizing this facility at all. This is where when you have some biomedical equipment from CSIO, we can do the CSIR certified. I mean, if I say NPL certified, you'll think that I'm biased and my NPL get above I want to take away your credit. So let's say CSIR certified equipment, we can have it. Right? And that improves the quality. The same thing with the reference materials. If you call it an RF, reference material, it costs 500 rupees. But once it is traceable to any metrology institute, it can be NIST, it can be in any country, right? It can be NPL India also. Once it is traceable, those values which we are measuring in our lab, that equipment is calibrated at NPL. Then you can call that what we are making, the same reference material. The values are certified or traceable to Metrology Institute, that becomes a certified reference material. RM costs 500 rupees, a certified reference material costs 5,000 rupees.
Sir, I have a question. What are the pros and cons of having more than one time zone? Why I am asking this question? Because geographically we see that sunrise and sunset takes place at different times. Let us take an example of Northeast states. They receive the sunrise first as compared to Western states. So what are the pros and cons of having 2 different time zones in the country? Let us say below football will have a different time zone, but above football will have another time zone. If it is possible.
Right. So the time zones concept comes because it's Earth is round and it's rotating along its axis. So it's 360 degrees, rotates in 24 hours. So 15 degree corresponds to 1 hour. Right? So if the geographical spread of any country is more than 15 degrees, if you want to have a very precise astronomical time connected to the solar movement or the Earth's rotation, then every 15 degree change, we should have 1 hour correction to the time. Right? But the challenges are that, okay, for India, from the westernmost to the easternmost, the change is about 28 degrees. So we should have ideally had at least 2 time zones with 1 hour separation each. The challenge is in that is coordination. Right. The classic example which is given in the time and frequency community is that, like, so for example, a train is going from one side and suddenly it changes. Like, after a certain latitude, the time is changed by 1 hour. The signaling has to take care of it. The driver has to be aware of it. If there are 2 trains coming from both sides, they are coming at 2 different times. One is 1 hour behind the other one. Right? So this is simply the coordination becomes extremely challenging. The banks working and opening at one time here and the other branches are not open. Right? And the way the exam papers are getting leaked. Right. So these are so many challenges, and they are simple things, but these are the challenges. And the infrastructure needed to run and operate, it takes hundreds of crores every year. Right?
No, I mean, countries like US and all do have time zones, and there are, like, various standard times. But they are sort of poised to it. Their infrastructure adheres to it, right? I mean, you see the time frame change as the plane lands in New York from, let's say, Midwest something. But that has to be done here. I mean, if you want to do, we have severe infrastructure augmentation needs. So coming back to your this slide on the Camp to Tesla, what's really the use case of it? Mostly that on clock.
It's a sensor.
It's just
It's sensor. So now if you have a femtotesla sensor, you can go up to 100 meters underground.
and then
Right, for the tunnels or water or any change in the G value because the density is changing. Right, so you can detect
that kind of precision.
Achanta, very thanks for insightful talk. So actually, in qubit, right, when we are talking about the low temperature qubits, so there are an issue of the phase changes because they are not maintaining the phase. And in photonics qubit, this problem is not there, right? So, as you have already shown in your slide, like some of the qubit you have already developed in the NPL, which is even can be transmitted to the classical channel, like to the optical fiber, right? So, has it demonstrated or like it is still in under the some lab type?
we are at the lab demo.
Lab, because at Delhi they have already demonstrated some qubit around 100 kilometer, right, on the 3-space channel as well as the optical fiber channel.
Right. That's again still in the lab, not in the open space, like not in the buried fiber and all that.
Yeah, but
So
they have open space, like one house versus another house.
Open air, yes, they have done, but open air has their own challenges because of attenuation. If there is rain or cloud or anything like so, it's going to affect. Yes, but yes, they have done.
But as we have our fab facility, for example, so don't you think like the QPICs and all, like they may be of the futuristic for the to generate the single photon as well as for the entanglement sources, right?
Yeah. So yes, that's my current research.
Yeah.
Or one of them is where started work about a year and a half ago. We made these lithium niobate based waveguides.
Right.
The idea is to launch light in these waveguides, generate the entangled photon pairs, transmit everything on chip, modulate these using different techniques for modulation tools, and basically detection also through these single mode detectors. So that's what we have actually made these modulators, and we are working on transmission channels. So lithium niobate and silicon nitride are the two areas which we are looking at. So we made both the processes are optimized.
They are at 15 between 15 and
1550.
Thank you.
I think there are no more questions, so let's give a very
Thank you, Ajanta sir, for such an insightful session. अब हम कार्यक्रम के अगले चरण की ओर बढ़ते हैं। किसी भी संस्था की असली पहचान उसके कर्मचारियों से होती है। वो लोग जो अपने समर्पण, परिश्रम और ईमानदारी से संस्था को ऊंचाइयों तक पहुंचाते हैं। आज का यह विशेष अवसर हमें यह सौभाग्य प्रदान करता है कि हम उन सभी वरिष्ठ सहयोगियों के प्रति अपनी कृतज्ञता व्यक्त करें जिन्होंने अपने जीवन के अनमोल वर्ष CSIR की सेवा में समर्पित किए हैं। आपकी लगन, निष्ठा और मेहनत आने वाली पीढ़ियों के लिए एक प्रेरणादायक उदाहरण है। अब मैं हमारे माननीय मुख्य अतिथि, हमारे विशिष्ट अतिथि एवं डायरेक्टर सर से विनम्र निवेदन करती हूँ कि वे हमारे आदरणीय सेवानिवृत्त सहयोगियों को सम्मान पत्र, शॉल एवं स्मृति चिन्ह भेंट कर उनका सम्मान करें। फॉरवर्डिंग दिस, मैं सबसे पहले मंच पर आमंत्रित करना चाहूंगी श्री हर्षपति, पूर्व प्रबंधक कम स्टोर कीपर। Please give a huge round of applause for the dedicated work in CSIR. Next is Shri Kani, पूर्व लैब सहायक। श्री सुशील कुमार शर्मा, पूर्व नीति सदस्य। श्री अशोक कुमार, पूर्व वरिष्ठ तकनीशियन। श्री जसवंत राय, पूर्व वरिष्ठ प्रशासन नियंत्रक।
सर टाइम करना सामने
श्री प्रकाश चंद, पूर्व कार्य सहायक। श्री हरिचंद सिंह, पूर्व प्रिंसिपल तकनीकी अधिकारी। श्री राकेश कुमार शर्मा, पूर्व लैब सहायक। Now may I further request our esteemed guest and director sir to kindly felicitate the employee who have completed 25 years of service. So in this line, I would like to call Shri Rajpal Singh Lab Sahayak. Now, on the occasion of CSIR Foundation Day, an open day was organized and CSIO lab was thrown open for students and general public. Around 350 visitors visited the lab and interacted with our scientists. Also, various competitions were organized for the children of CSIO staff, and we were truly amazed to see their enthusiasm, creativity, and remarkable talent. So today, to recognize and appreciate their wonderful performances, we will be distributing prizes to these talented young participants. So in this line, I would like to call all the participants. So first competition was निबंध प्रतियोगिता. इसके लिए प्रथम पुरस्कार जाता है वंशित चंचल सुपुत्र श्री सुनील कुमार. द्वितीय पुरस्कार जाता है छवि सुपुत्र श्री विक्रम. तृतीय पुरस्कार जाता है अभी खोबरा सुपुत्र श्री विक्रम. Kindly encourage them with a huge round of applause, please. इसके साथ ही प्रोत्साहन स्वरूप हम प्रतिभागी प्रमाण पत्र दे रहे हैं आदित्य जरवाल सुपुत्र डॉक्टर मनीष कुमार और दिव्यांश जांगीर सुपुत्र श्री सुरेंद्र कुमार जांगीर. ये किसी कारणवश यहाँ उपस्थित नहीं है. तो मूविंग ऑन, नेक्स्ट वॉज भाषण प्रतियोगिता जिसका प्रथम पुरस्कार जाता है सुहासिनी सुपुत्री श्री अभिषेक चंद्रा. द्वितीय पुरस्कार जाता है उपासना सुपुत्री श्री गौरव सिंह. अगली प्रतियोगिता थी कविता कहानी वाचन प्रतियोगिता जिसमें प्रथम पुरस्कार जाता है केवल्य सुपुत्र डॉक्टर मनीष कुमार. द्वितीय पुरस्कार जाता है पार्थ शर्मा सुपुत्र डॉक्टर पूजा. तृतीय पुरस्कार जाता है यशिका सुपुत्री श्री सुरेंद्र कुमार जांगीर. Actually, they have a tie for the third prize. तृतीय पुरस्कार जाता है साजन सुपुत्र श्री हरप्रीत सिंह शेखो. इसी में प्रतिभागी प्रमाण पत्र जाते हैं विशाली सुपुत्री श्री पंकज कुमार, तनिष सुपुत्र श्री चंद्रपाल सिंह, अर्शिया सुपुत्री डॉक्टर अपर्णा, रियांश सुपुत्र श्री सुनील कुमार, नव्या सुपुत्री डॉक्टर वीडी शिवले.
पार्टिसिपेट कर लेते हैं.
Tanishq.
अगली प्रतियोगिता की ड्राइंग प्रतियोगिता, जिसमें नन्हे कलाकारों ने बहुत अच्छी कला का प्रदर्शन किया है, जिसमें प्रथम पुरस्कार जाता है मिशिका सुपुत्री श्री चंद्रपाल सिंह। द्वितीय पुरस्कार जाता है वेदांत सुपुत्र श्री सर्वेश कुमार। तृतीय पुरस्कार जाता है मायरा मानुषी सुपुत्री डॉक्टर मुकेश कुमार और अनामिका भारद्वाज सुपुत्री डॉक्टर सौरभ कुमार।
ले लिया सर्टिफिकेट नहीं था, नहीं सर्टिफिकेट था, सर्टिफिकेट 90 देता हूँ। आ जाओ, हाँ इसको दे दो पहले।
इसके साथ ही प्रतिभागी सम्मान पत्र जाते हैं यांश कश्यप सुपुत्र श्री दीपक कश्यप। करू तन्मय सुपुत्र श्री नरेंद्र सिंह। दर्शिका सुपुत्री प्रियंका गुप्ता। चित्रांश गुप्ता सुपुत्र डॉक्टर अभिषेक गुप्ता। मोक्ष सुपुत्री श्री रविकांत। आर्यांश सुपुत्र श्री विष्णु सनारी। हार्दिक हर्षित सुपुत्री श्री नरेंद्र सिंह।
आ जाओ ले लो
ये बच्चे का है।
Heartiest congratulations to all the kids and their parents. बच्चों ने जिस उत्साह और लगन से भाग लिया वह न केवल प्रेरणादायक था, बल्कि इस बात का प्रमाण भी है कि CSIR-CSIO परिवार की नई पीढ़ी कितनी प्रतिभाशाली और उज्जवल है। देश का भविष्य बिल्कुल सुरक्षित हाथों में है। Now it is our privilege to honor our chief guest, Professor Venu Gopalachanta, Director, CSIR New Delhi, and our guest of honor, Dr. Sanjeev Khosla, Director, MTech, for gracing this celebration with their presence and inspiring words. Thank you so much, sir, for gracing the occasion. May I now invite Dr. Satish Kumar to kindly deliver the formal vote of thanks.
Thank you. As you know, we are celebrating CSIR Foundation Day. And the foundation, if our foundation is strong, then we can make any pillar. And that's why CSIR is known as a air, because everywhere its presence is seen. And on this auspicious day, we are thankful to the Professor Gopal Achanta, who came from Delhi, our sister concern, and has given us an insight about the NPS, what are the different domains of NPL, and also extended sport where we can collaborate in the environment and medical domain where he is looking into. And also we like to see a lot of good innovation like single photon detectors, quantum computing he is already working, and a lot of other initiatives. As he mentioned, the uncertainty is 0.035, and also the time is also highly accurate over 2 nanoseconds. Really, sir, we are proud of you and proud of our laboratories, and also we are thankful to Professor Sanjeev Khosla, Director IFM, who is always with us, stand with us, and because of your presence, we are also feeling honored, sir. Really, we are thankful to you. And we are also thankful to our retirees because who has contributed for the success of this organization by different aspects. And we are also thankful for the participation of the kids and thankful special to the parents who motivated for the participation in these kinds of events because these are the real true future of the country. And we are also thankful to Director Professor Shantanu Bhattacharya who always motivated to do this kind of an event in a good way. And this event which we are seeing, there are a lot of people behind us, like Narendra Kumar ji Jassal, Mansi is doing all these kinds of anchoring, and Dr. already Lord Lokesh ji is doing all kind of arrangement. So all, because it will be difficult to mention the name of all. So I am thankful to all, and last, all the students and also the colleagues, because without you this event is not successful. Thank you very much. Thank you all of you.
Thank you so much, sir. I now request everyone to please rise for the national anthem.
जनगण अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उज्जल जलधि तरंगा तव शुभ नामे जागे तब शुभ आशीष मांगे गाहे तब जय गाथा जन गण मंगल दायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय जय जय